Hello and welcome. In today's class, we'll be looking at another KMap problem, and this question is taken from ISC 2023 Council paper. So in the first part of the question, we are given a Boolean function f of 4 variables, a, b, c, and d, and the min terms of this Boolean function is given to us. So when we look at this summation sign, we realize that these are the min terms. So we have to reduce this expression using 4 variable KMap. And we have to show the various groups, octal, quads, pairs. And once we have reduced the expression, we have to draw the logic gate diagram for the reduced expression. So this is how we have to draw the KMap. And because we are going to reduce it in SOP form, because min terms are given, so we have to reduce it in SOP form. These are the possible combinations for the 2 variables a and b. And these are the possible combinations for c and d. And we have put 1 in all the min terms of the KMap. So all the numbers that were given there, according to those values, we have put 1s in all those places. Now, after drawing the KMap, we see that octals are not possible, but quads are possible. And this is the first quad that's possible. This highlighted portion is a quad. And we try to reduce it. So I have written down the expression, the SOP expression. So for this one, because it is in A0, B0 row and CD column, so for this one we are writing A0, B0, CD. Similarly for this one, this is also in A0, B0 row, but this is in CD0 column. So accordingly, we have written the term for the second one. And so on. All the terms are written down in SOP form. And then we reduce it. We simplify this quad. So we see that in this SOP, A0 is one variable which is not changing. And c is another variable which is not changing. That's why the reduced term will be A0C. Whereas B0 is changing because B0 is changing to B in the third term. D is changing to D0 in the second term. But A0 and C remains the same throughout. So this is our first quad reduction. Another quad is possible. This is the second quad, which is highlighted in green. And here also we have written down all the min terms and we have reduced it. So here B and C are the 2 variables which are not changing, and that's why BC is the reduced term. And finally, we have these 4 forming a quad. Because when we do map rolling sideways, these ones will join with these 2 and a quad will form. And so we reduce this one also and we get AD0. And now we write down the reduced SOP expression in SOP form. So A0C, so SOP means sum of products. So sum of products of all the terms after reducing each and every quad. So this is our reduced expression. We took all the reduced values and added them to form an SOP expression, the reduced SOP expression. So this is our answer. And now using this logic gate diagram, we are implementing that reduced expression. So for A naught C, I took an AND gate, for B and C also, and for A D naught also. And then using an OR gate, we are combining all three values and we are getting this as the result. So the first part of the question is solved. Now let's look at the second part of this problem. So in the second part of the problem, we are again given one Boolean function of 4 variables. But here the max terms are given. When we look at the pi symbol, we realize that these are max terms. And here also using KMap, we have to reduce the given expression. So here also using the 4 variable KMap, we have to reduce this expression and we have to show the octals, quads and pairs while reducing. And after that, we have to draw the logic gate diagram for the reduced expression. So this is how we have drawn the KMap. Here, max terms means all those places where we are getting zeros in the Boolean function. So we have put zeros in all those places. So A plus B, and this actually indicates 0 plus 0. So here zeros are uncomplemented and ones are complemented. So once we have put zeros in all those places where we have our max terms, now we are ready to reduce this expression. So again, octals are not possible, but in this corner we can form one quad. And we have written down the POS expression for this quad. So this 0 is in A plus B row and C plus D column. So we have written A plus B plus C plus D. This 0 is in A plus B row but C plus D naught column. So we have written A plus B plus C plus D naught. So these are written in POS form. And we see that A and C are the 2 variables which are not changing throughout this expression. And that's why we get A plus C as the result. This is another quad that is possible. So here again we are writing down the POS and we see that A naught and C naught are the 2 variables which are not changing, which remains the same throughout this expression, and that's why the reduced term is A naught plus C naught. And we know that in octals always 2 variables are removed, and so we are left with 2 variables. We had earlier 4 variables and now we are left with 2 variables. And this is another quad that's possible. We have zeros in all 4 corners. As a result, due to map rolling, this also can form a quad, and so we have written down the POS expression for this quad also, and we have reduced it to B plus D because B plus D remains the same. And this is our reduced POS expression. So all the terms are taken down and written down in POS form. Once the POS expression is done, we can draw the logic gate diagram. So for addition, we have used the OR gate, and for ANDing them together, we have used the AND gate, and this is our complete diagram. That's all in this class. I hope you have understood how to solve this KMap problem that came in the year 2023, paper 1. Thank you for watching and see you in the next class.